Am I audible?
Sure.
Okay. Uh, I am Prolay Sharma. I will take your digital signal processing class in this semester. So, how many students you have in the class? How many students you are in the class? Hello. Anyone please respond?
So 60.
60. Okay. Okay. Let's say let's share the screen. Uh, Screen is visible.
Yes, sir.
Okay. 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 Let's continue then. So this semester we will learn digital signal processing. In short, it is called DSP. So, digital signal processing, the subject consists of three terms. One is digital, then signal, and processing. So, this digital, what is digital? Digital means some discrete, the signal represents by some discrete numbers. And signals, I think all of you have little bit exposure with the signal. Signal is basically a variable, a variable component that represent that conveys some information. In short, if we want to define signal, it is basically signal is basically this is in some okay. Signal is basically a variable parameter whose varies with respect to some independent parameter and conveys some information. We can take the example of today's, suppose today's temperature. Usually, in the morning, the temperature is usually be a little bit low. Then, as time progresses, temperature goes up, and then again it decrease after some time. So if we see the profile of temperature variation, it will first increase, then it will into decrease. So if we consider, so in the independent axis, time will be there. In the dependent axis, temperature. So this is the temperature change profile of any days. So this is also called a signal. So any variable um, variable parameter whose varies with some independent parameter, independent variable is called a signal. Suppose voltage signal, current signal. This also voltage changes with respect to time is called voltage called DSP. We will learn what is signal, what are the different classification of signal, what the different operation can perform on signal, and what are the different characteristic feature of the signal. In details, we will study. And then last, processing. So processing means we will process the signal such a way uh, for the betterment of the signal. Uh, we we do various type of processing. So for the betterment of the signal, the various processes performs is called processing. So now if we put up a formal definition of DSP, so DSP is defined as a changing or analyzing information which is measured and as discrete sequence of numbers. So here DSP stands for digital signal processing. So whatever the signal we will process are digital in form. So that means to analyze the information in the discrete time sequences, digital signals. So this is called the processing. So what are the different type of processing we will do? So main task for processing is the betterment. Is the main criteria. So processing can be any many thing processing. So to clean up the noise, so to introduce some feature, so to to reject some band of frequencies. So various kind of thing we can do. So in this subject, we will learn various type of processing technique. To process the signal, what are the different system we have to implement. So that we also see in this subject. So first, processing means processing will be done some system. So there will be some system that will do the processing thing. So first we have to know what is the system. System is basically an interface between input and output. That means a system will take some input and it will provide some output. And what are the what is the operation of the system does is called processing. Now the basic elements of DSP, digital signal processing. In real world, all the signal we receive are analog in nature. Sound wave, any kind of signal we receive is in analog form. This is called signal input. Now, to process the signal under digital signal processing, first we need to convert the signal in discrete form. That means we need to convert the signal to discrete signal. So how to convert a signal to discrete signal? The standard process is first we need to sample the signal, then approximation of the sample values, then suitable encoding system. During this process, the analog signal gets discretized. Then here in this block, the signal we receive is discrete in nature or digital in nature. Then some processing will be done with that signal. So suppose this is the signal. It's coming from some. This is a speech signal. So it first this is the microphone. This is the microphone. This microphone will convert the acoustic signal to corresponding electrical signal. Then this electrical signal will come to the process called A to D conversion process. That means the electrical signal will convert is discretized with this analog to digital converted unit. So some bits in suppose 0, 1, 1, 1, 0. Suppose we receive this bit string. So DSP, this is the DSP processor we have. So it takes this digital signal. Suppose after processing we are getting the bit string like this 1, 0, 1, 1, 0, 0. So you see that the input bit string and output bitstream are different. That means some processing is happening in between the input and output, which is called the digital signal processing. This processing has been done on digital signal. So this is the bitstream. Now it is converted to into electrical form, and it is basically, and then it is converted to digital to analog converter. It is passed through digital to analog converter, and we receive. Suppose this is the electrical analog signal. Again, the input signal is acoustic signal, analog acoustic signal. So need to be convert the this signal again back to acoustic signal. So how to convert it? We need to a speaker. So then acoustic signal generates and it reaches towards through air to our air, it enters to our brain and it interprets. So suppose there are some in processing means, suppose there noise elimination, this kind of operation we are doing with the DSP processor, then we will get a clean noise clean signal, and that our brain can interpret. So this is the basic block diagram of DSP. That is, analog signal will be there. It will be converted to digital signal. There is some processing will be done. Then again, the digital signal is converted to analog signal. So there is a question maybe arise in our mind that, so every time an analog signal is there, it again converted to analog signal. So why in between analog to digital conversion process and again digital to analog conversion process? Why we are doing? So first of all, it is necessary because the digital signal processing, it takes only digital signal and it provides the digital signal uh, output. So signal has to be converted in the in form in a digital form. Otherwise, it can process. And secondly, if the signal is converted into digital form, then lots of advantages we can get. The advantages like it can process digitally. So digital processing means digital circuits are very easy to construct. The tolerance level is temperature tolerance level, component variation tolerance level. So these parameters are susceptible uh, in digital circuits. Suppose if temperature changes, a music system, what the music produces in Siberia and also in South Africa will be same for the digital circuit. But if this circuit is analog in nature, then obviously due to temperature difference, we know that the transistors and all other electronic components consist with the analog circuit has huge temperature, has some temperature effect, and due to temperature variation, the parameter for the analog devices changes and the output also changes. But in case of discrete circuit, that doesn't have digital circuit, that doesn't happen. Significant changes doesn't happen. And the component tolerances, that means we know that two transistors beta good the same. And in analog circuit, so this component tolerances have a significant effect. But in digital circuit, it doesn't effect. So many advantages are there for the digital system. That's why we are taking digital system. So in parallel, there is another branch of engineering called analog signal processing that is also there. That is a different subject. So there is analog signal is directly processed. But here in this branch of engineering, we are doing the processing of digital signal. So digital signal processing again characterized two way. One is real-time signal processing, another one is non-real-time signal processing. So real-time processing means suppose radar signal, suppose some unidentified object is coming, radar is sensing the uh, uh, that object. So it has to be processed real time. Otherwise, the precautionary arrangement we can take. We can we can arrange the precautionary arrangement. So the radar signal and the speech signal. Suppose I am talking and you are listening. That the process in between happening in the wireless communication has to be done in real time. Otherwise, the communication process will not be a valid, fulfilled one. The purpose will not be fulfilled. So this is called real-time processing. And another layer is non-real-time processing. Suppose we capture a signal, a photograph of certain object, and you will next you will pass through some different image processing algorithm, and to get the insight of the photograph. So this is called non-real-time processing. So after taking this signal or information, we will process later. So it is being stored first, then processing, and whatever the processing is carried out, that carried out is non-real-time basis. So this is called non-real-time signal processing. So advantages of DSP, there are numerous advantages of DSPs are there, but the main three advantages are listed here. First one is versatility, repeatability, simplicity. Versatility means suppose we make one filter today. Suppose we want to change the filter characteristics after 2 days. So what we will do? You will write some code or you will read some code. That means it will change the software program. Then the filter characteristics or filter performance will be changed. So this is called versatility. In analog, suppose in analog circuit, you have made one filter through an op-amp and transistor and other active components, analog components. Suppose 2 or 3 days after you want to change the performance of the filters, then what we have to do? We have to desolder and solder many components. So, with respect to versatility, the obviously a software program which is implemented the DSP algorithm concept will be much easier. So versatility and adding of new functionality will be a very simple one and doesn't need to alter any hardware changes. And then repeatability. So digital systems can be easily duplicated. That this system do not depend upon component tolerance and temperature. That is already explained. So repeatability means suppose in Siberia the temperature is too low. Suppose you are playing one music there, and same music you will get if you play the music in the very hot place. Suppose in South Africa, you will get the same music. So temperature tolerance will not be there. Due to temperature variation system, there will be no changes in the output. So this is called repeatability. The system is highly repeatable with respect to temperature changes and as well as other component parameter changes. And simplicity. So simplicity, digital system is basically built some basic 4 or 5 components, suppose adder, subtractor, multiplier. So these are the delay. These are the 4 or 5 components. Using 4 or 5 components, you can build any type of complex system. So, and system building is very simple. So, as it is implemented in software form, so it makes very simple process. So now here the application of DSP is summarized. So first application is image processing, the field where it is used, pattern recognition, animation, robotic vision, image enhancement. Then the second application of DSP is instrumentation and control, and fields where it is used are spectral analysis, noise reduction, data compression. Then speech and audio processing. It is used in speech recognition, speech synthesis, equalization, etc. Then biomedical application. In DSP is widely used in biomedical instrument. Mostly all the instruments in biomedical field are at the classic example of DSP applications. Suppose it is if it is MRI, CT scan, ECG, um, all the and USG. So in every instrument, biomedical instrument, there is an application of DSP. Next, telecommunication, echo cancellation, space spectrum, data communication, encryption, um, security, so data compression. So many in many field in communication, DSP is applied. In military also, suppose radar signal processing, sonar processing, secure communication, that is cryptography called, uh, is the application in military. So these are the applications of DSPs. Now we have to concentrate on signal. Uh, we have already defined what is signal. So signal is basically it conveys some information. It is describes some mathematical equation involving independent and dependent variables. So the signal can be uh, defined like this way: a physical quantity which contains some information and which is a function of one or more independent variable. So one or more independent variable, how it is possible? Suppose suppose we have a picture, black and white picture. So what is picture? Picture is basically, if we consider it is a black and white picture, then we can define it as the distribution of changing gray level is basically black and white photograph. This is the two-dimensional image space. Two-dimensional space, the gray level is distributed. Now, if we consider black and white to color picture, then every pixel in black pixel will be composed with 3 different values RGB. So next, the sources are made 3 sources are coming. One is R, another one is G, another one is B. So and that independent variable is the XY plane. Plane is the independent variable, and dependent parameter is distribution of gray, red, blue, and green level. So, so this is called a number of variable. Here, number of variable increased. Now, if the signal is a moving signal, then again extra one independent variable is coming. That is, as it is, if the pictures changes with respect to time, then again extra variable time is coming. So this way the independent variables are increasing. So independent variable may be one or many. Now if we classify the signal can be classified into this way. First one is continuous or discrete signal. Second one is continuous valued or discrete value signal. Third one is whether signal is periodic, non-periodic signal, even an odd signal, energy and power signal, deterministic random signal, multi-channel and multi-dimensional signal. This way we can classify the signal. So multi-channel, we can set an example of that movie color movie picture. We can say that multi-channel is three channels are there and multi-dimensional also. So let's define one by one. Now continuous signal. A signal of a continuous signal is that means that in every time instant we will get some value. That is called continuous signal, or you can say analog signal also. Every time instant we will get certain values of the signal, and the signal is changing continuously. So this is called continuous signal. So this is one continuous signal, another one. This is also continuous signal. So mathematical expression, if we consider sinusoidal signal like this, so the this is not a so if we consider this sinusoidal signal, then the mathematically we can express xt equal to a sine omega t plus phi. So here a is xt in bracket t is written because x is changing with respect to t. T is the independent variable with respect to t. The xt is changing. And here in the right hand side, the a is called the amplitude of the signal. Psi is the description method of the signal nature. If it is varying with the signal is very sinusoidally according to this mathematical function, the signal is varying. Omega is angular frequency. Angular frequency is omega. It can be represented by 2 pi f into linear frequency, 2 into pi into f, where f is in hertz, and phi is the phase shift of the sinusoidal signal. So this is a mathematical expression of any continuous signal. Now discrete signal. So we said last couple of times before that a signal can be converted into discrete signal by doing some operation. First one is sampling, then approximation. So suppose this is the continuous signal, and this is the train of impulses. Impulse signal we will later use in details. We will see what is impulse called impulse. Just you can for understanding for this point of time, you can say that impulse is a very short duration pulse, which is very tends to zero. Width of the pulse tends to zero. Now with this train of pulses means, so many pulses are there after some time, definite time period. Many such kind of impulses are there. So it is called train of pulses. Now if we take as a sampling function means this signal will be used to sample the signal. Suppose we have, so what is called sampling? Suppose we have some coins. Suppose 1 rupee coin. Suppose we have 10 coins, and if we pick up one at a certain point of time, it is called sampling. So sampling means after a definite time we are taking some what is the value of the signal. Suppose at t equal to 1 second, suppose the this is the value of the signal. So we are picking up that sample. Suppose t equal to pi, this is the value of the signal. So if we pick up this value, then it is called sampling. So with a large volume of data, we are picking up some definite values. This is called sampling. So to do in real time, what we are doing, we are multiplying with the continuous signal with a train of impulses. So to what will happen? So if you see the impulse here, the amplitude of the impulse is taken as 1. So if the signal is multiplied with 1, the value will be itself. So in between two samples, there is nothing, 0. So if we multiply the signal, then this sample value will be multiplied with the value here of the signal at the time, and then next sample value will be multiplied with the value particular this sample. So in between T1 and T2, we will not get anything. So after multiplication, we will get this 1, 2, 3, 4, 5, 6, 7. So these sample values we are getting. So now after multiplication, the signal is not become a continuous one. After some time, suppose 0, 1, 2, 3, some definite time instances, we will get definite some points. So these points are called sample values. Now the signal is being a discrete signal. So this is called a discrete signal. That is, the signal is not continuous. For discrete time instances, we will get some discrete values of the signal. So this is a continuous signal and this is a discrete signal. Discrete signal consists of some discrete numbers. And continuous is a huge information. Is every time instance there are many every time instance we have the value. That means enormous information is present for in the continuous signal. But here in the discrete signal, we are not taking all the values, all the details of this signal, but we are taking some sample values of the signal. So number of storage to store this type of signal is reduced drastically. But here, if we want to store this continuous signal, so we need much larger memory space, because here infinite number of sample values are present. Now, suppose this signal, a staircase like a signal. So here we see that for 0 to 1, the amplitude is 5. And in the next instant, 0 to 2, the amplitude is 10. This way, 2 to 3 seconds, the amplitude is 15. So here, if we observe, then we can understand that this, after with the variation of time from 0 to 4 seconds, the amplitude of the signal is changing in this discrete way. From first 5, then 10, then 15, but we are not getting the value in between 5 and 10. So this type of signal is called continuous amplitude, continuous time, because the time axis is continuous, but the amplitude is changing in a discrete manner, the discrete amplitude signal. So continuous time discrete amplitude signal, though the signal is not discretized, but the amplitude is changing in a discrete manner. And here also, if we observe similar kind of signal, here you see the time axis get discretized. So from 0, 1, 2, 3. So in between 0 and 1, nothing is there. So in between 0 and 1, so we have the amplitude 5. But in between 0 and 1, 2 or 1 to 2, so no sample values are present. we are getting sample value at the time position 1, 2, 3, then 4, 5, 6. So the amplitude is discrete. So 0, 1, amplitude is 5, 3, amplitude is 5, again 4, amplitude is 10, 5, amplitude is 10, 6, amplitude is 10, and 7, amplitude is 15. So here you can understand that in the previous case and this case, the amplitude is getting discretized due to staircase type. Uh, but here in the addedly in the right hand side plot, the time axis is also discrete. So this signal is called discrete time. Here it was called this continuous time, but in that case it is called discrete time and discrete amplitude signal. Here it is called continuous time discrete amplitude signal, but here we are calling it discrete time discrete amplitude signal. So the difference is there between these two signals. So now periodic and non-periodic signal. So if we know very well in the previous class, I think you know periodic signal. Periodic signal means suppose we can, if we assume this type of, if we consider this type of signal, then we can observe that the same shape is repeating, the signal repeats same shape after some definite time period, this shape. So again this shape is coming again. So after definite time, the same shape is repeating. So this time is called time period. So after some specific time, the signal is repeating again, again and again. So this type of signal is called periodic signal, and mathematically it is written by this form. Xt is the signal. So if we advance the signal by t0, t0 is the time period, that means this t0. If we take the advancement of the signal with t0, then same thing is repeat, same thing will come. So after t0 time, what you will get is the same thing with the previous one. Again after t0 time, we will get the same replica of the signal. So this type of signal is called periodic signal, and the mathematical equation of periodic signal is this: xt equal to xt plus t0. It is in continuous time, and for analog signal, if we consider a discrete signal, then the mathematical equation will be written is xn. N is the discrete numbers. N is the discrete time instances: 0 second, 1 second, 2 second, 3 second, like. And like capital T, capital N is the period of the signal. Capital N is the period of the signal. So the mathematical equation in the discrete domain is being represented by this: xn equal to xn plus capital N. So capital N time after the signal will repeat again. So this is the periodic signal in analog domain, and this is the periodic signal in discrete domain. So what is non-periodic signal? The non-periodic signal doesn't obey this mathematical condition. That means after there will be no repetition of the signal any time. So there is no time period kind of thing we will get in non-periodic signal. After that, the signal shape will be repeat again. So this kind of phenomena doesn't happen in case of non-periodic signal. So this equation will not hold for the non-periodic signal, and that type of signal is called this mathematical equation doesn't valid. This type of signal is called non-periodic signal. An example is like that. Suppose this is the exponentially decaying signal. If we consider, then gradually the signal will go tends to zero amplitude, but this signal is not on seeing the signal we can't assume that the signal will repeat again. This shape will repeat again. So we can consider that the signal is a non-periodic signal. Then we can take one example problem. So, so first we have to determine whether the signal is periodic or non-periodic, and what will be the fundamental period of the signal. First example is xn is the signal, which is defined like this: cos n by 8 into cos pi n by 8. So left we consider this example, then we can see that here if we think the signal is like that, xn equal to cos omega 1 t cos omega 2 t, then the angular frequency will be 1 by 8 was the first term of the multiplication signal, and the second this for this expression the frequency will be pi by 8. Now omega equal to 2 pi f we know, so 2 pi f1 equal to 1 by 8, so f1 will be 1 by 16 pi and f2 will be 1 by 16. Now the condition is that this is the multiplication of two signals. So first signal, the f1 is a ratio of non-integer values. Here you see that in the denominator 16 into pi, and pi also all of you know is a 3.14. Okay, this value. So it is not a integer, non-integer value. It will be rather it is a fractional value. So the rule is that if the signal is a ratio of two non-integer values, then the signal will be non-periodic. So first expression, this signal cos n by 8 is a non-periodic signal. For the second signal cos pi n by 8, you will see that f2 equal to 1 by 16. So f2 is a ratio of two integer values, so it is periodic. And again, the signal is basically multiplication of one non-periodic signal and one periodic signal. So multiplication of non-periodic and a periodic signal will result a non-periodic equation. So with this we can conclude that this xn, as it is multiplied with it is a resultant of multiplication of non-periodic signal and periodic signal, then xn will be a non-periodic signal. So now the second example, if we consider, this is the second example, then if we find out this composed of three signal. One is this cos n pi by 2, second one is sin pi n by 8, and third one is pi n by 4, and there is a added phase difference is there. While we are considering for periodic and aperiodic signal, then phase difference doesn't imply any significance to it. So phase difference doesn't matter. It doesn't added any criteria for its periodicity. So we can't simply ignore that phase shift. So now if we find out its frequency, then for the first signal, the angular frequency is pi by 2. For the second signal, angular frequency is pi by 8. And for the third signal, the angular frequency is pi by 4. Now, if it is converted into linear forms, then F1 is coming as 1 by 4, F2 is coming as 1 by 16, and F3 is coming as 1 by 18. Now the condition of periodicity, if we consider, then the F1 is basically ratio of two integer, F2 is also ratio of two integer, and F3 is again ratio of two integer. So we can say that these these three signal are periodic in nature. So as a resultant, that is addition and subtraction, if we do with that signal, the resultant signal will be a periodic one. So in our example, the first signal is coming as non-periodic and second signal is coming as periodic signal. So, so next one is odd signal and even signal. So we know very well what is odd function and even function. So odd function will be event signal will be like this: x minus t. If we replaced t by minus t, then uh, it will come as xt. So if we replace t to minus t, but it doesn't affect the signal, so expression. So this is called event signal. This is a definition of event function. Now, how it is pictorially, how we can understand it is even or odd. Suppose if we have this kind of function. So in event function is basically symmetric with respect to horizontal axis. If a signal is symmetric with respect to horizontal axis, then it is called a event signal. So if we place a mirror on the x-axis, we see that whatever the this part will be symmetric with respect to this mirror. So this is called a event signal. And here also for this signal, if we place a mirror, then the reflection part is symmetric with this part. This portion and this portion are symmetric with respect to the horizontal axis. So this is called a even signal. In case of discrete signal, we can see this signal is again symmetric with respect to horizontal axis, and this signal is symmetric with respect to horizontal axis. So these two signals are even signal. Now for the odd signal, the odd function is like this. This is the odd function minus xt equal to x minus t. All of you know. The odd signal is symmetric with respect to the origin. So if we see this signal, then this part of the signal and this part of the signal is symmetric with respect to origin. And here also this signal, this sinusoidal signal is symmetric with respect to the origin. So this is called odd signal. And if we consider the discrete signal, so this signal is symmetric. This signal is symmetric with respect to origin. So with that, we will continue the next classification of the signal in the next class. So that is energy signal, power signal, deterministic signal, non-deterministic signal. This classification we will continue in the next class. So if you have any question, you can ask me. Okay, so if you don't have any question, then let's take today's attendance.
So will you send the PPT of the class?
Yes. All the PPT I will send you in your. If you all you please respond to the invitation of the Google Classroom. Please join to the Google Classroom. So I will send all the notes after completing the one segment or one PPT. I will send you in the WhatsApp in the Google Classroom. You will collect it from there. So let me finish this portion. I will send you through Google Classroom. Okay. So please respond one by one. First, Ovirup, tell me your roll
Yes,
number.
sir. Sir,
Tell me.
092.
Then Oniket,
Sir, 065.
then Anindita,
Sir, 079.
Anirban,
084, sir.
Anik, Ankit,
047, sir.
Orijit,
So 094.
Aryan, Aryan Sardar. Roll number, please.
2078.
Arnav,
So 070.
Ornik,
Sir, 2093.
Arpon,
Sir, 302 chapter 1
no, no.
02.
You please tell me last two digits of your roll number.
স্যার আমরা ল্যাটারাল থেকে তো
ওকে ওকে কত ল্যাটারাল বলো কত?
হ্যাঁ 302 চারটে 1
2 ওকে
02 002.
Okay. Okay, 002. Okay. That means you can tell me a lateral 2. Okay.
Okay.
Ashraf,
Sir, 075.
Uvik,
Sir, I mean lateral, so 2004.
Ovirup,
098.
Ayushman,
060.
Biplab,
051.
Gulshan,
091.
Himanshu,
102.
Joita,
Lateral 2001.
Moinak,
052.
Mohammad Nasruddin,
Sir, lateral 2007, last 07.
আচ্ছা মিথুন
088.
হুসেন মানুর
081. Sir, 001.
001 001 Okay, Nilagro
Sir, it is 001.
8001 and Nilagro Roy Okay, Nishant roll number
Sir, mic কাজ করছে না. 090.
090 Parvez
074.
প্রসেনজিৎ,
081.
সন্দীপর্ণা,
044.
সপ্তর্ষ,
Sir, 2002.
শাহবাজ,
041.
শিল্পা,
083, sir.
শিখা,
032.
03, শেখ মুস্তাফা,
Sir, 09.
সোহম,
082.
সৌমিক, সৌমিক,
Sir, 095.
সৌমজিৎ,
068.
সৌরভ,
048, sir.
সূর্য,
089.
সঞ্জয়,
Sir, 076.
শ্রীতমা,
Sir, 100.
100, 100,
Sir, 100.
মানে লাস্টে 3 ডিজিট। আচ্ছা আচ্ছা, ঠিক আছে। শুভলিন,
29, sir.
29, সুরজ, সূর্য,
স্যার
Sir,
ওটা
zero-
সৌর্য তোর নাম্বার
সৌর্য।
তোরটা আমি দিয়ে দিয়েছি মনে হয়।
আচ্ছা তোমারটা বলো।
স্যার
Sir,
আমার
আমার
হচ্ছে
099.
099, আর তোমারটা
স্যার আমার 089।
089, ওর তো সূর্য, আর তোমার সূর্য।
Sir, সৌর্যর 099.
সূর্য আর সূর্য দুজন।
হ্যাঁ স্যার।
ঠিক আছে। শুভজিৎ,
Sir, 086.
086, তমাল,
Sir, lateral 2005.
নেক্সট হচ্ছে উদ্ভাস।
066.
তোমার নামের উচ্চারণটা কি?
Sir, উদ্ভাস ঠিকই আছে।
উদ্ভাস, কি বললে না?
066.
066, বৈভব,
Sir, 006.
006,
ওর
okay,
মাইক কাজ করছিল না।
okay, thank you all of you for attending the class. So next class will be on Friday, so I will send you the link to your Google Classroom. Please attend the next class, and after that I will send you the PPT. Okay, thank you all of you.
Sir,
ওকে
হ্যাঁ
স্যার একটা জিনিস জিজ্ঞেস করবো?
হ্যাঁ
বলছি যে স্যার ওই ডিসক্রিট সিগন্যাল আর কন্টিনিউয়াস সিগন্যালের ক্ষেত্রে মানে কন্টিনিউয়াস যেটা কন্টিনিউয়াস ভ্যালু পাই আর ডিসক্রিটটা কিছু টাইম ছাড়া ছাড়া পাই, তো স্যার যখন স্কোয়ার ওয়েভ একটা নর্মাল স্কোয়ার ওয়েভের ক্ষেত্রে আমি তো মানে কন্টিনিউয়াস 1 আবার কন্টিনিউয়াস 0 এরকম কন্টিনিউয়াস পাচ্ছি, আবার স্যার কিছুক্ষণ ছাড়া ছাড়াই আমি 1 আর 0 পাচ্ছি, তাহলে ওটা মানে কন্টিনিউয়াস হবে না ডিসক্রিট হবে?
দেখো আমরা একটা এক্সাম্পল দেখালাম, স্টেয়ারকেস সিগন্যালের এক্সাম্পল দেখালাম, দেখলে তো ওখানে ওটাও তো প্রায় অনেকটা স্কোয়ার সিগন্যালের মতোই, অ্যাম্পলিটিউডটা চেঞ্জ হচ্ছে। ওখানে কি হচ্ছে আমাদের তোমার ওই সিগন্যালটাকে আমরা কিভাবে ক্লাসিফাই করলাম, ওটাকে বললাম যে কন্টিনিউয়াস টাইম ডিসক্রিট অ্যাম্পলিটিউড সিগন্যাল। ঠিক আছে, তাহলে তোমার ওটার ক্ষেত্রেও তাই হবে, কন্টিনিউয়াস টাইম ডিসক্রিট অ্যাম্পলিটিউড সিগন্যাল। টাইমটা তো ডিসক্রিট করা হয়নি। ওকে,
বুঝতে পেরেছি স্যার। ওকে স্যার,
হ্যাঁ, okay, thank you. So I am ending the class here. You will meet again on Friday.
থ্যাংক ইউ স্যার।